Welcome, friends, to Science Talk. I am your host and resident oceanographer, Jim Massa.
Hello, everyone. Hi, Jim. It's so good to have you back. We are tonight. This is Jim Massa, oceanographer extraordinaire, and Science Talk with Jim Massa. Welcome. We are going to do an ocean update tonight. So, we are going to talk about everything to do with the oceans. And then we have an intermission video, and then we are going to talk about the current situation with the dismantling of the ocean monitoring systems and what that entails and what it doesn't entail. But it's great to see everybody. And hello, Kim. Thank you for moderating. And hello, everybody that's here. Kim and Anthony and Alex and all of you. Looney's here. And this is great. It's great. Mr. Poik, hi. Good to see all of you. Some new people here and everybody that's watching us on X and on Facebook tonight. Facebook is also live. So take it away, Jim.
Well, first of all, it's good. Hello, everyone. Good to be back. As Sandy said, we've got a lot to discuss. So I kind of grouped this into several categories. We'll talk about AMOC. We'll talk about the coming super El Nino. We'll talk about what's going on in the Southern Ocean, for example, with the ice. And we've got some stuff to talk about methane from the oceans,
Methane.
and as well as the role of eddies and sea level rise. So a lot to discuss. Um, what's interesting in looking at these articles, it occurred to me that this is stuff I was saying years ago, and
Mm-hmm.
it looks like now it's finally being people are catching on. Not that I'm any great genius to anything. I was just simply looking at the data, and I was just being a competent oceanographer. But
Yep.
it's people have been ignoring the oceans for a long time, looking only at the atmosphere. And I keep saying the oceans drive the climate, and I think people are really starting to come around and understand that yeah, that's what the hell happens.
Well, we've talked about these things on our, for years on our show with you also, and doing the updates. And And there's always new AMOC. How many AMOC shows have we done? And there's always new updates on AMOC. And then everybody says, oh my God, it's going to happen. And, Europe's going to freeze and blah, blah. So we try to temper that a little bit in relationship, because I know how you feel in relationship to all the other issues that are happening that. So I don't know. We'll find out if you've changed your tune at all with AMOC, right?
Well, no, we'll discuss it when we pull up one of the
Yeah.
articles. But um, as I think the last time we were did a podcast together, we discussed that paper that looked at the strength of AMOC over like 60 years or so, and the
Yeah.
conclusion was it hasn't really changed whatever.
Mm-hmm.
And I did a further breakdown of the last 20 years, and I
Yep.
showed using regression analysis that it something is happening. Well, basically the consensus is that yes, something is happening. It is slowing down. Now, it's slowing down. It's not like, oh my God, it's going to
It's
stop.
right. That was a great show, by the way. And I learned a lot in that show. That was really good for me.
Oh, thank you.
Yeah.
Stefan Ramstorff basically said that the data is indicating that, and we'll see this later,
Mm-hmm.
that AMOC will probably slow by about 51% by 2100.
Yeah.
He
2100.
said it could lead to a full stoppage beyond that, but we just don't know.
Of course not. Well, that's
But it's going to
science.
be slowing down, and we can discuss what that means as far as what the UK and the Scandinavian folks, in fact, all of European folks can expect weather-wise.
Mm-hmm.
Um, it could get a bit unpleasant.
Mm. Yeah. Well, a lot of things are getting unpleasant. And as much as people want to be in denial or fight or be trolling or saying nothing's happening, it is. I mean, it is. And that's just the way it is. All right. So, what do you want to do? Should we go to our screen and start sharing the articles? Start looking at the articles?
Sure, we
All
can.
right.
Let's start with the AMOC ones.
Yep, let's take it away and get the screen up. And this is the I think this is the first one.
Yep,
Yep.
sure.
Okay.
And we're not going to like read every single word in all these articles because we have something like 11 articles that
Right.
we set aside for tonight. But we're
Mhm.
going to do a little synopsis here. So, as this title says, the Atlantic current shows a 2-decade decline across 4 deep ocean monitoring sites. Go back to what I just said a few moments ago. When I did that analysis of the last 2.5 decades, I, we found a significant slope indicating that AMOC was
Yes.
slowing. Here it is. It's backing this up, showing a 2-decade decline in the Atlantic current. So, papers published in Science Advances adds more evidence that AMOC is weakening. Okay, not like collapsing. I hate that word. It's not accurate. People should stop saying that. Weakening, yes, it is. Okay, so what they've done is we all know what AMOC is, so no need to go over that. But what they did was researchers from the U.S., UK, and Canada they set some mooring arrays, right?
Mhm.
Mooring. We'll be talking
Mhm.
about that later in the second
Mhm.
half. And these arrays are anchored to the seafloor along the western side of the Atlantic. In other words, off the eastern seaboard,
Mhm.
from the Caribbean all the way up to basically the maritime provinces of Canada. And they measured ocean bottom pressure and other ocean water properties below 1,000 meters. So basically, we're getting just underneath intermediate water level, getting into the upper layers of the where the deep water would be found.
I went and read this whole thing. I liked it. It was interesting.
So by calculating changes in pressure along the continental slope, you have the continental shelf, and then the slope is where uh, the the rate of decline to the bottom hadal regions steepens, so you get a steeper decline down into the ocean basin. And what they found was uh, a consistent trend rather than any fluctuations. And the decline wasn't just one spot, but across all the spots there. So they identified a meridionally consistent decline in deep western overturning transport across these latitudes over the past 2 decades. What does that mean? That means if they're showing a decline in the western side of the ocean basin of the overturning transport. That means your deep water formation back up in the northern Atlantic is
Mm-hmm.
slowing down.
In the northern Atlantic.
And if that's slowing down, that means the North Atlantic drift, which branches off the North Atlantic gyre, off the Gulf Stream, that's slowing down as well. So,
But
so this,
again, not slowing down tomorrow, but the slowing down is actually happening.
yes, it is.
Yes.
You know, it is indeed. Now, 25 years ago, if you asked me what the slowdown means, I said, oh, yeah, it's going to push us into a cooling phase because the
Mm-hmm.
evidence of the proxy data of the past shows
Mm-hmm.
us when AMOX slows or stops totally, that the northern hemisphere cools down. Sometimes it helps promote growth of ice sheets.
Mm-hmm.
Now I say it's going to be regional because of all the ocean heat and the rest of the oceans. That's going to account for something.
Right.
So so that's what this article, and that's the synopsis of this one here.
Mm-hmm.
That they're actually measuring a direct slowdown in the overturn, meaning the deep water formation, which means that the sinking at the surface has to be slowing down.
Wow. Wow. Let me see if did they have the writers. They had the writers, but the scientists actually on the paper, a very interesting bunch from all over.
Yep, yep.
Mm-hmm.
And this is what happens when you have collaboration, among scientists.
Yes.
You know, so it's just unfortunate that well, other factors at work. Let's just put
Right.
it
We
that way for
know.
now.
We know. Yes. It's very sad. Very sad. Okay, well, let's move on. I don't think these people in the administration even understand any of this. No.
No, they
Okay.
don't.
All right. And we move on because phys.org is an excellent publication and they really are the go-to, and then they link to the science, you can look at it, and this was another one I was reading, and very interesting research, I think.
I I pretty much get most of my material from whenever I put videos together from pretty much phys.org and EOS. Um,
Yeah.
for what I call my summary headline type of videos. I go to other sources if I want to do papers with deep dives.
Mm-hmm.
Pretty much like the AGU, the
Yeah.
Journal of Geophysical Research,
Mm-hmm.
JGR. I look at those places there. So here we go again. Same thing. A vital Atlantic current is fading far faster, threatening Europe, Africa, North America by 2100. And I think this is the one where Stefan is featured in here. So let's start off looking at this, I think, very helpful diagram.
Mm-hmm.
And as you can see, you've got the red is the warm water. It's also surface water,
Mm-hmm.
and then you have the sinking in the North Atlantic, and you becomes the cold blue, indicated in blue, deep current that flows back south, and there's the start of the conveyor
Ooh.
belt.
Thick. Yeah.
So, looking at masses of warm surface water travel carrying nutrients, carbon, and oxygen. So when you really, to sum it up, why is the conveyor belt important for climate? It brings warm water and nutrients up north, so it helps moderate the climate at higher latitudes. And then the return of cold water back south to help cool down lower latitudes
Yes.
and the equatorial regions. So when you get up to, look at number two there, the waters cool down by releasing heat in the atmosphere. Remember that the Gulf Stream is also very salty. It has a high salinity. So when you cool it down, it becomes cold water, and salty water makes it quite dense, and it sinks vertically through the water column. That's what traditionally has happened. However, thanks to the warming of the Arctic, 4 to 5 times more so than the rest of the planet, we're having major melting of the Greenland ice sheet. It's dumping fresh water onto the surface in the North Atlantic, diluting the salinity. So now that water is not as dense, it doesn't sink. This is part of the slowdown that we're seeing that's being measured.
Yeah.
Now, when sea ice forms, we discussed this before. You have brine rejection, so then you have the same amount of salt, but now the volume of liquid water is decreased, so the salinity in essence increases, making it more dense. That helps with some of the sinking. Until you throw Greenland's ice melt in there, and then that just kind of throws a big old wrench in the works. So this cold, it says here, number 4, masses of cold salt. That's the key word. Salt water are dense and sink, and that's the process we call deep water formation. So that is in essence, the mechanism behind the conveyor belt flowing.
Mm-hmm.
Now, this diagram doesn't take it into the southern hemisphere, but there's another vitally important reason why the slowdown in deep water formation is crucial, and that is what happens in the Southern Ocean. Normally, this deep water flows south, and as it's flowing south, it's mixing with other water masses, a little bit of friction, it starts gaining a little heat, it starts rising. As it rises, it's also bringing nutrients with it. It rises in a region called the Antarctic Divergence Zone. It's an upwelling. Basically, it's a big ass upwelling. And it brings lots of nutrients that fuels the Southern Ocean ecosystem, the food web down there.
Yes.
That brings the nutrients for the phytoplankton, for the krill, right, the zooplankton krill, which feeds the baleen whales, etc., etc.
Yeah.
If you slow down the deep water formation, you're going to slow down this upwelling in the Southern Ocean. You're going to negatively impact the food web down there. That's a major concern.
That's a major concern. A huge concern. Huge concern. See, I saw in this where they said previous climate model projections estimated an average slowdown of 32%, and now it's 51%.
That's according to Stefan by 2100.
Yeah, yeah.
So,
Sure.
so it's a key Atlantic Ocean current system that helps regulate the planet's climate could weaken more than expected by 2100. That's that 35 to 51 we just mentioned. And okay, right.
Yeah.
But we already discussed how it redistributes heat and so on. And AMOC, okay, they say collapse. I wish they didn't. Well, AMOC weakening
Mm-hmm.
could lead to harsher winters in northern Europe, droughts in South Asia, and the Sahel region in Africa. It could lead to higher sea levels in North America, among other consequences. I'll get to that in a moment about the sea levels.
Yeah,
Right?
we have another article.
Previous climate model projections have estimated an average slowdown around 32%, but 51% by 2100 according to other modelers and the work that they done. So, scientists, oceanographers are obviously concerned, as they should be.
Wow.
And so, changing, it's like everything else in science. You get more data, more understanding of the system. You then make adjustments and
Mm-hmm.
reassessments.
Right.
According to the IPCC, AMOC will very likely decline over this century. Oh, how very nice of them.
How very nice of them. Okay.
Some of the projection ranges vary from a little 3%. That's throw that out, up to as much as 72%. I would consider those two values to be outliers. So if you were to do a five number summary, and those would be the low and high values. You then want to find the median, and the median is the 32 to 51%,
Mm.
for the slowdown.
Right.
So so
So,
so that's
okay.
okay. Here it is. Ramstorp. Okay, he was not involved in this particular study, but this is
All
AMOC
right.
would be so weak by 2100 that would very likely be on the way to full shutdown.
And this is when the deniers call us alarmists. It's
I don't
not
give a shit what they say.
happening. It's not happening. Yeah.
And we all know that Stefan is pretty much an AMOC expert.
Yeah.
It's like,
I think we know that. Yes.
yeah.
Definitely. Yeah. Okay.
So you know, so when he says that, we need to listen to him. Um, he says very likely. He didn't say it's going to happen. It is very likely. We can do the best. We can only do so much with the modeling, but that's what the modeling are suggesting at this moment here. So
That's 75 years from now. Think about it. It's not that far for like the
no.
lifetime for people's grandchildren they're still having kids and it's their grandchildren, you know? Really. It's
So
going to
now, what does this mean for the for weather for the folks in Europe, Scandinavia, the UK, right? Well,
Well,
if
wait a
you
minute.
don't,
Quickly, would it be weather in 75 years or weather in 25 years? I mean, give us a like the slight little variations.
let's just say as the century progresses,
Mhm. Okay.
what's likely to happen is that, first of all, you don't have the North Atlantic drift moving northward. So you don't have that heat being given off. That heat
Right.
moderates the region. That's why the UK is warmer than it should be. It's why it's also wet. They're
Mhm.
pretty wet there
Mhm.
because of all that moisture there. So if you lose that heat of fluxing to the atmosphere, you're going to expect a cool down. So you can expect to
Yeah.
cool down, but also you have to look at what's happening with the jet stream, because the jet streams are changing from zonal to meridional flow, so it goes up and down like
Mhm.
that. So it could bring warm, it could bring cold. It could be oscillating. You can get weather whiplash, but also
Yeah.
how does this interact with the North Atlantic oscillation? Switching between Iceland and the Canary Islands, the high and low
Ooh.
pressure system, and how that directs, the jet stream, and how that directs the temperature and precipitation pattern. All that going to get jumbled up.
A lot of things.
So
Whew.
you could see some drought conditions, say Southern Europe. You could see a cooling down in Northern Europe. Cooling down in the Scandinavian countries
Mhm.
in the UK.
Mm, mm.
So there's as this progresses, it's probably going to get worse and worse.
Lovely. Lovely.
So yeah, so folks might need to start investing in parkas.
Well, people have to be cognizant that, your children if you're having children and they're going to I mean, you have to start teaching them these things. And the schools do not do that. I don't know about other countries. I know in the United States that's not happening. There's no preparation for anything that's potentially going to happen. And that's a tough one. I think it is, at least in this era. Maybe we will get out of the Trump era. Maybe there's some sanity that will come back, but I think it's going to be a long time.
Uh, Unfortunately, I share your
Yeah,
sentiments.
I know you do. We do share a lot of the same sentiments. All right, let's see. We're
So,
moving on to. All right, we're going to move on to what everybody's talking about, El Nino, and it's not a kind of salsa.
no, this one is shaping up to be a super duper El Nino.
That's what
Uh,
they're
if
saying.
you if you look at the SST, tracking, it's already like flying off the charts. I mean, it's probably like already like seven standard
Oh
deviations
yeah,
above.
Elliot Jacobson is doing a lot of work on this. He's got his climate casino going. He's really, yeah. We got to bring you two back on together for an El Nino talk.
Yeah, it's and finally, if you look, oceans absorb around 90% of the excess heat generated by human activities, 93%. But finally, they're actually saying
Yeah,
that the atmosphere is only absorbing like 2%, 2 to
but is
4%. That's
that
it.
getting to the mainstream? Or is the mainstream? I don't know what the mainstream talks about, but this is not a mainstream publication. But is are more mainstream publications finally talking about this because of the El Nino? I mean, we've had other El Ninos. We had one what in 15 and one in 23, I think it was. But this one is different because of the contributions humanity has made to the to the earth. Yeah.
Well, here's another thing. Going back to what might happen in Northern Europe as AMOC slows, what have you.
Yeah.
If you were to to take into account the various aspects of the Milankovitch cycles,
Mhm.
okay, looks at the precession, looks at the tilt of the axis and the eccentricity of the orbit, what have you. If you were to look at that now and say humans were not on the planet,
Right.
the positioning of those three major aspects of the cycle, planet Earth currently right now would be in a cool down phase. It would be cooling down.
Oh, yes.
The fact that it's warming up, the planet is warming up, we are actually contributing 133% of the warming. In other words,
Yeah.
we've negated the cool down that the Milankovitch cycles would indicate, and then we've added two on top of that.
Alex
Think,
says
ab-
El
think about that.
Nino is crashing the party. Crashing the party. Oh
And,
God.
and El Nino is really going to push things. We're
Yeah.
going to see record temperatures for the next couple of years as long as this lasts. And of course, don't forget with the oceans, you got the lag effect.
Yeah. You've taught us about that. Mhm.
So it's not, oh, El Nino's done. That's it. We cool down. Oh, no, no, no. It's going to
No.
linger. It's going to linger.
Okay.
So what does the
So
EU say? The EU climate monitor says that the ocean temps are edging towards record highs to a potentially powerful El Nino. Yeah, yeah,
mhm.
yeah.
So, Jim,
Right?
we're going to be looking a lot more at Copernicus, and we're going to be looking at a lot more other countries' climate scientists and universities and work as the United States keeps defunding and phasing out ours.
Yeah,
Yeah.
yeah.
Hmm.
We are. We've lost the satellites. Now we're going to lose the damn ocean monitoring.
Yeah, we'll get there because there's a lot to say about
I,
that.
yeah, I really do have a lot to say about
I
that,
know you do.
and and it makes me blood a wee bit
Well,
boiling.
yeah, because that's your field. Losing that's your field. You may not be actively working right now in it, but that's your field and you use these things. So,
Yeah,
okay, so Zeke, what did he say at Berkeley Earth? It's an independent climate research organization, and he wrote last week a strong El Nino could significantly raise the chances of 2027 becoming the hottest year ever recorded. And Zeke is kind of conservative, so here he's saying it.
right,
Yeah,
right, exactly.
yeah,
I mean, and by the way, you just mentioned Copernicus. Well, here Copernicus is overseen by the ECMWF.
yep.
You know,
Here we are.
so we got all these marine heat waves, you know, like going on. Um, Now, of course, El Nino is part of the ENSO cycling,
Yes.
but I've said this before, and I'm going to keep saying this again, just to put this in perspective. The coldest La Nina of today
Mm-hmm.
is still warmer than the hottest El Ninos of 30, 40 years ago.
Wow. The coldest El Nino of today. Or La Nina. Wait, what did you say? Say it again.
What did I say?
The
The coldest,
coldest
coldest La Nina
La Nina of
of
today.
today is warmer than the hottest El Ninos of 30, 40 years ago.
Oh boy. That's a good one. I have to make a meme. Shit. Oh my gosh. Yeah.
So if we're talking about an El Nino that's going to be off the bloody charts here, just think how crazy this is.
Well, we all better prep for 2027. Those of us that are growing our gardens and food and trying to get everything ready to prepare. I mean, I don't know how it's going to be on the east coast of the United States. I think it's the Pacific is going to be affected a little more dramatically with rain, wetness, and maybe potentially really I don't know, we'll see. We have to do another chapter on the effects, but I know
Yeah.
2027 is going to be a tough one. And well, I'll be around this channel, I hope, still, if I don't kick the can like I every other week I say I'm ending the channel. But I don't. You know why? Because everybody in this chat I love. I love you all. Yeah, that's the thing. Y'all keep me coming back to educate. And my team, Jim. All right. So, are we ready to move?
No, I still want to say a few more points here
Okay.
on this article.
All right.
Get into the section of extremes. So Copernicus said the upturn in ocean temps over March and April indicated a transition from neutral conditions to the El Nino was underway. Now they say that El Nino alone is not driving the extraordinary ocean warmth. Yeah, it's called ocean heat content. And basically, what they're saying is that April was the third hottest globally and 1.43 C above the 1850 to 1900 pre industrial benchmark. Arctic sea ice remained near record lows in April, while Europe endured varied conditions that set the stage for a hotter, drier summer at risk of drought and wildfires.
Okay, there you go.
We're just getting
Okay.
extremes and extremes and extremes. That's what we're getting.
So, have your masks ready for the wildfire smoke,
Yeah,
unfortunately. Yep, I'm still
yeah,
got all that crap. It was what 3 years ago. I think I that the those terrible Canadian fires. 3 years was it 2023? I was outside gardening with a freaking mask on. It was just so awful. And the pictures I took, it was pretty bad. And I felt so bad for my fellow Canadians. Oh my gosh. I hope. I
yeah,
mean, you hope that you don't see it happening again, but you know that you can't say, "Oh, it never say never," because it's just going to.
yeah. We had the fires all across Canada, all across the boreal north at some, the circumpolar north at some point, Scandinavia. Alaska, Siberia, were
Yes.
all having our fires. Australia had nasty, nasty fires. Like what was that, 6 years ago, something like that? I mean, like the whole continent burned down. It
Yeah.
was just really brutal.
I know.
And this is what happens with all the you know mucking up the system.
Great. Okay.
So let's see. The next one I have queued up is a giant warm wave is crossing the Pacific, signaling an El Nino that could alter weather worldwide this year. And waves of higher, warmer water move eastward across the Pacific Ocean a few months before an El Nino emerges.
Yeah, this was really interesting actually reading this and visualizing the water levels higher in these certain places. Oh man.
And this showed up in 2026 satellite data,
Mm.
data that U.S. no longer is going to have access to.
Here in this country. Right.
Yeah.
Mm.
Sea level data from a satellite launched by NASA before the cuts and the pulling the plug, and European partners shows that a swell of warm water hundreds of miles wide has arrived in the Pacific Ocean off the coast of South America, a sign that El Nino is likely to manifest itself. Warm water expands as it warms, right? So you get
Mhm.
an increase in sea level in those locations, and that goes along with the increasing ocean temperatures. El Nino can cause heavy precipitation in some regions, deficits, translation droughts, in others. And of course, that affects life, farming, etc., etc. So, the satellites that they've looked at, the Copernicus program, the Sentinel-6, um, you know, they they map water height for the entire ocean every 10 days, and it's so
Oh,
damn accurate that they can get it down to fractions of an inch.
wow. That is damn accurate. Phew.
And we actually call that mapping what's called geodesic heights.
Oh.
And so
Mhm.
that's basically what they're mapping there. And the satellite tracks what are called warm Kelvin waves. Kelvin waves are basin wide waves in the
Mhm.
ocean, and they're common in the Pacific. And they go west to east, so they go right across. And typically, they're low latitude to equatorial hugging, so they hug the equator. And then when they reach North America, South America, they kind of deflect and they kind of move poleward, either north or south, depending which side of the equator you're on, and then make a return. But it's a warm water wave. It's also churning up the water column, not churning as you think in like active mixing, but it's entraining some of the water that's at
Mm.
deeper in the water column. And if you got warm water in the water column, it helps bring that with it, bringing warmer water to the surface to help bring in an El Nino event.
Oof. Yeah.
And so these waves typically form after brief periods when winds over the far western equatorial Pacific Ocean shift from prevailing easterlies
Easterlies.
to westerlies.
Yeah, that was interesting to read.
And that's, in a video I did years ago when I discussed, and so it talked about how the shift in the winds and the positioning of the low pressure system
Mhm.
helps, it contributes to the oscillating between the La Nina phase and the El Nino phase, with usually a neutral in between. Here we're adding another mechanism of the Kelvin waves. So, when you get the weakening of the easterly winds along the equator, the water in the tropics of the Western Pacific gets warmer, sea levels rise, then this wave that forms because you have the water level rose, so the water column is taller at that point there, so it's going to follow the pressure gradient, and because it's pretty much on the equator, it's going to flow straight. Not going to have Coriolis acting on it, and then it helps with the Kelvin wave, then pushes this west to east.
The other way. Gosh. And it forms an east for several weeks, eventually reaching
Yeah.
South America, causing water off the coast to heat up and rise. See, that's what I was visualizing, this hot water and rising on the coasts where all these people live, Colombia, Ecuador, and Peru.
And
Yeah.
that's there because multiple Kelvin waves appear over the course of several months and
Wow.
push this warm water eastward.
Wow. Wow. So I feel for people that are going to be a little like or could be very displaced.
So basically, what this is, it's providing another contributing mechanism to how El Ninos form.
Mhm.
And when you have all the ocean heat there, well, that's more potential sea level rise or water rise, which is
Wow.
increasing the geodesic heights, which then increases the pressure gradient, and then the waves help push it along.
Wow. That's pretty cool.
Because in the ocean, water flows down the pressure gradient. It goes from the where water column is higher, it flows down to where the water column is lower.
Stay tuned as more ocean stories continue to unfold. Well, we're
And
staying tuned.
warmer sea surface temperatures in the central and eastern Pacific affect atmospheric circulation patterns worldwide by shifting the jet stream. And
Yeah.
we know the jet stream impacts the storm events.
Yeah.
So you can get heavy precipitation, some areas, unusual heat and dryness in others.
Yeah.
How far away depends on the strength of the El Nino. If this one is going to be a super duper off the charts El Nino, impacts are going to be major and worldwide felt.
I hope the world is preparing. I know there is a lot on El Nino on social media. I don't know exactly how much is in the regular news cycles in the United States. I mean everybody's so caught up in the wars that some of this stuff just gets pushed aside, but I don't want to see people shocked, and wildlife, not preparing wildlife for this too. These things affect, it's not just people, it's the
No.
environment, it's wildlife, it's zoos. I mean, think of zoos. They're all those animals are at the mercy of the zookeepers. There's probably zoos that are in places that are going to be affected. So this was interesting. The tracking El Nino, the fishermen in the 1600s coined the name El Nino, Spanish for the boy, a reference to the birth of baby Jesus because it tended to intensify around Christmas time, and warmer waters meant they would catch fewer fish. So that's how it was started. It was the beginning of being recognized that the changes were coming, and they were tracking it way back when. And leave it to fishermen, leave it to the water babies, right?
Yep. Exactly.
And so,
Yep.
but that's
Yep.
just interesting because they knew when it was coming and how they called it, they called it a little boy. Wow. Yeah, and here it says the heavy rain and snow in some areas and unusual heat and dryness in others. So it's going to be a wild ride, I think. And according to
Yeah.
what Elliot's talking about, yeah, he's definitely all in on the wild ride. Okay, what do you want to do? Where are we going?
So basically, it's as Betty Davis famously said in All About Eve. fasten your seatbelts. It's going to be a bumpy ride.
There you go, Faya. And we're in for a bumpy ride. Oh God. We'll be here with you guys. We will be your collapse support specialists. I promise I will be here. I will not give up on you. I will not ditch anybody. I will be here no matter how crazy my life is. All right, now let's move on to the Antarctic for our update. I thought this was
Yeah.
definitely some interesting news here from March. This was from March.
Yep. Rapid melting of Antarctic sea ice is largely driven by shock ocean
Yeah, a shock.
warming.
Like we didn't know
It ain't the atmosphere,
that.
which I've been.
Yeah.
How long have I been like yelling into the abyss about
For
this?
every show. Yeah. It is
It's the
because of the water
ocean
under
heat.
the heat underneath. Yeah, absolutely.
I've done how many programs have we done? How many
Yes.
videos have I posted
Yep.
where I explain the mechanism of the water coming in from the Pacific and the Indian Ocean, getting
Yes.
entrained in the Antarctic, deep circumpolar current and upwelling and melting the ice from below, and then
Yes.
and melting the cantilevered land ice that protrudes
Right.
past the grounding line. I've been talking about this for
Of course.
years.
And so many people don't understand that. They say, oh, it's the atmosphere. It's because the sun is getting to the top. But that's really not comprehensive. That's not the
It,
comprehensive
it's just
explanation.
it's just a small contributing
Yeah,
factor. You get a lot of nice melt pools on the surface, but
sure.
that's
But that's
but
not what's causing the calving, is it?
no,
Or the
because
no, it's from underneath. It goes. I
remember,
wish I had a
water
visual.
water has a higher specific heat than air, which means if you have a cubic meter of air and a
Mm-hmm.
cubic meter of water, there's a
Yep.
lot more heat energy in that water than the air, which means it's going to do a lot more impacts.
God. I thought this piece that right here when they talked about the Arctic sea ice has been steadily declining since satellite measurements of sea ice. Antarctic sea ice has exhibited a completely different behavior. After expanding slowly for several decades, just slowly, Antarctic sea ice declined rapidly in late 2015 and has experienced large year to year fluctuations in extent. And people love to grab onto that and say, see, it's not happening. Antarctica is just the same, which is not Antarctica.
Yeah, I mean, it's always it's a complicated system,
Yeah,
and the data
absolutely.
actually shows that when the northern hemisphere cools down, the southern hemisphere warms up, and kind of vice versa.
Mm,
So, if the northern hemisphere is warming up, which it is, then I guess part of the balancing of the heat budget, you're going to have a slight cooling phenomenon in the southern hemisphere to a point. And the point is, as the ocean heat accumulates in the Southern Ocean, that's what happened, I think, in 2015, why it reversed, because the ocean heat in the Southern Oceans got to the point where, oh, it's now impacting ice a hell of a lot more.
yeah. I want to put this up because this makes sense. I think media in general is brainwashing America, not just ads. Of course, because they're not going to tell us. They're not because then it connotates alarmism and it's Al Gore and it's bull and it's lies and I read today on one of these idiot threads. Oh, even Greta has given up on the climate because it's a hoax, and now she's traded it for her the scarf, the Palestinian scarf. And come on, people. I sometimes, Jim, I really can't do social media every single day because I really feel like in the beginning when it talks about we're in the Anthropocene, we're in the Moronocene. I always say that. The Moronocene, at least in the United States.
Who would have thought that Idiocracy was a documentary?
Right? Yeah. I know. A lot of people love to point that one out. So let's go down to the
So
protective
yeah,
layer
that
here.
exactly where I wanted to, you know.
Read
So there's
your
a protective
mind.
layer of cold water beneath the sea ice that prevented warmer deep water from rising and melting the ice from below. But during the winter of
Uh,
2015, storms in the Southern Ocean were unusually strong, reducing this protective layer, and then that allowed the warmer water to reach the
Caffeine.
ice
Yes.
and start melting. So water masses with large differences in salinity and or temperature do not mix easily and settle in layers on top of each other, right? That's stratification.
Hmm.
Although you do have what's called double fingering diffusion that takes place. And usually temperatures differences will mix more readily than salinity differences.
Okay.
And that can then affect the movement. So
The
the cold
stratification.
winter water layer that protects the sea ice becomes increasingly fresh as the ice grows from more sea ice melt.
Hmm.
This increases stratification. Basically, you're diluting. That's you're
Okay.
decreasing you're decreasing the salinity. That's what that's
Okay.
saying. Okay,
Hmm.
and as you melt the ice because the ice sea ice is called sea ice because the source is the sea, but you still have brine rejection. So when you form the ice, you're going to increase the salinity. But when you melt the ice, you're going to decrease the salinity, and when
Right.
you do that,
Obviously.
you get stratification.
Yes.
So the storms will, they kind of stirred things up a wee bit, and the winter water layer has thinned over large parts of the Southern Ocean, allowing deep warm water to approach the surface. The storms in 2015 stirred up the sea, and warmer water mixed with the cold water layer. The protection disappeared, and the ice melted at record speed. And that, so
Record
20,
speed.
about 11 years ago. And I
Yeah,
love
I
this one
remember
here.
this. Oh, the elephant seal.
The elephant seal. Elephant
I
seals help scientists.
I know, but I was looking at that going, does it hurt them? Or do they not know it's on there? I was looking, I wanted to see it closer. How do they, I mean, how does that stay on? It looks kind of yuck.
They, they actually use an adhesive
And it stays on in that
to
water.
to a point, and then eventually
Yeah.
it falls off. But
Yeah. And then,
as a,
it was $30,000 little thing.
they didn't want to use they didn't want to use a strap because that would impede the
No,
animal's movement.
that would be awful. So it must be
You
an
know,
amazing adhesive. It probably doesn't hurt them. But as I was looking at it, I was like, "What the hell?" When I read that, because of course, guys, I prepare these shows. I mean, I read every single one, of course. Everything I do with Jim, though, I really study the oceans. I really do. I mean, it's not like I don't with Antonio, but I really study because I'm fascinated by the oceans and by the science. And because I've learned so much, it's just amazing.
so we have a mechanism that explains the reversal in the extent of the sea ice for Antarctica.
Hmm.
Basically the storms, and I think the next uh, article is really telling. Um, that's the one about the triple whammy.
Yeah, climate chaos. Sea ice collapse driven by triple whammy. Now there's a title that all those trolls on on X will love. No, sorry, in case I don't want to offend any. We're alive on X. I'm not offending anybody.
Yep, and there's some nice ice floes. A couple little penguins on that one there, kind of like,
Oh.
hey, what the hell's going on? So Antarctica is being basically pummeled by a triple whammy of climate chaos that has melted sea ice to record lows. And so, what's this? What have they discovered? University of
What
Southampton
have
showed
they?
that a series of compounding events flipped the Southern Ocean out of balance,
Yeah, that was wild
bringing
to read.
yeah,
Yeah.
you know, bringing unusually warm, salty water from the deep up to the surface. It was so extreme that it wiped out vast areas of ice equivalent to the size of Greenland. Holy moly!
Oh, here we
Okay,
got a new name, Jim. Wait a minute. I got to bring this up. Okay. My name for it is coming true global climactic catastrophe. Fuck. I remember that one. Thank you, Groove. Jeez. We don't mean to laugh, but if you don't laugh, you're going to cry. So, as we're doing
Cat-
this. But that was a
cat-
good one.
cat- catastrophe. I
Yeah.
think
Catastrophe. Catastrophe.
catastrophe.
All right. We're in the
Like
catastrophe.
catastrophe,
Yeah,
catastrophe. I
we're in
get it.
the
Okay,
era. Yeah,
that's
the
clever.
era of
That's clever.
catastrophe.
Yeah,
Yay! Where's the applause for that one?
climatic
Yeah,
catastrophe.
there we go. Thanks, Groove. All right, yay! Interactive with our people tonight. All right, now.
So basically, what Dr. Narayanan, uh, she's basically um, her data is supporting the data that we just talked about, reported on, that since 2015 there's been a transformation in the region, and she goes on to say that what started as a slow buildup of deep sea heat under the Antarctic sea ice was followed by violent mixing of water, ending in a nasty cycle where it's too warm to let ice recover.
Oh,
And that's a reference to those storms that
yep.
we mentioned in the prior article. So what's this triple whammy? Okay, sea ice decline happened in three stages, driven by shifting winds and warming oceans. Around
Where am
2013,
I?
strengthening winds began pulling warm, salty water from the deep ocean, known as the circumpolar deep water. You've heard me discuss that numerous
Oh
times
gosh, yeah.
before. It
Yes.
goes, runs around Antarctica.
Mm-hmm.
So basically, you have the wind pushing the water. So if you're pushing the water away, then conservation of volume says we have to replenish it, and the replenishment comes from the warm water that's underneath it. Now you're going to say, but I thought warm water is less dense than cold water. Well, this warm water is also saltier. So when you looked at it, it happened to be denser than the cold, not as salty surface water, just like we see up in the North Atlantic. In 2015, intense wind mixed the deeper heat directly to the surface layer, resulting in rapid sea ice melting. And then since 2018, the ice ocean system has become trapped in a cycle where, with less ice to melt, the surface remains salty and warm,
No.
inhibiting new
Yeah.
ice from forming.
Makes sense. Obviously. So this is a big
And
thing. This three stages of collapse of sea ice. Mm-hmm.
and it seems to be like self-perpetuating current conditions.
Mm-hmm.
So the study also found a striking asymmetry in how the ice is retreating across the continent, with East Antarctic loss almost entirely ocean driven, fueled by an upward surge of warmer deep water, which I have talked about numerous times. But in West Antarctica, heat was trapped in the ocean by intense cloud cover, which was funneled by warm air from the subtropics down to the pole, melting the sea ice during the summers of 16 and 19. That's an interesting mechanism. So basically, you brought in warmer subtropical air, and
Mm-hmm.
it sat over the ice, and well, it's warmer, so it's going to, you know, erode the ice. So, you know, so that's what's so that's is an explanation for the loss of the sea ice around Antarctica. We of
Wow.
course discussed the loss of the land ice numerous times,
Right.
but and keep in mind, if you lose the sea ice is a buffer, kind
Mm.
of like a fence to hold back the land ice. And if you lose that, there's nothing pushing against the land ice. The land ice just starts galloping off the continent,
Jeez.
and then
Galloping
it
off the
breaks off.
continent.
Then it breaks off, and then the current's bringing it to lower latitudes where it melts, and then because that's land ice, it contributes to sea level rise.
Wow. There we go. If the low sea ice coverage prevails into 2030 and beyond, the ocean may transition from a stabilizer of the world's climate to a powerful new driver of global warming. What are you talking about? It already is. I mean, okay.
Yeah.
Ugh,
So
yeah,
it's worrying. Let's put it that
it's
way.
worrying. And guess what? Now we are going to move on to methane. Are we moving on to methane?
We're moving on to methane.
Yeah, too bad Jennifer's not here. That's one of her favorite topics. Methane. We used to go, methane. Perma methane. Okay. Here we
Which one
go.
which one did you pull up? Oh, the hidden.
Yeah.
Okay, there we go. Okay, hidden ocean feedback loop could accelerate climate change. Yeah, think the world's ocean may be quietly amplifying climate change. In which way we're only beginning to appreciate. In a
Hmm.
new study published in the Proceedings of the National Academy of Sciences.
University of Rochester, not far from me.
Yep. It's funny because if you take the first letter proceedings of the National Academy of Sciences, it says an interesting word, PNAS.
Penis. Penis. Okay, Jim. We are in a mood tonight.
Well, it's all
I
relative
know.
because of the major dickhead that's in the
The orange penis. The
yeah.
orange mushroom, sorry. The orange mushroom.
Yeah. Well, he is a fungus.
Wow. When Kenny first found us, he found Environmental Coffee House by searching for where's that comment? By searching for methane. That's how he found the channel. That's wild. That's wild. Yeah, we used to do a lot of work on methane. Look at that. Very cool. Very cool. Bella Lagrisi, darling. Hey, listen, he's a wonderful person. He set up this studio that I'm in. He came to the house and set it all up for me. It's about time for
Cool.
a revamp, babe. Yeah. Okay.
So the mechanism that they describe could intensify as the planet warms. So in other words, they're talking a positive feedback loop, and we know that positive feedback loops exacerbate whatever the situation is. So we know that how powerful methane is. So what they did was they the findings point to a specific microbial process that is responsible for methane production in the ocean environment. Certain bacteria generate methane as a byproduct when they break down
Ooh.
organic compounds. But they only do this when phosphate is scarce. Well, phosphate is scarce to begin with. So it means that when phosphate is more scarce.
Oh, bad.
So phosphate scarcity is the primary control mechanism for methane production emissions in the open ocean.
That's wild. Wow.
So, what they are getting at here are
Mm-hmm.
biogenic sources of methane versus thermogenic sources of methane, where you just have these trapped methane pockets and you get some sort of process and then you get this big flush of methane
That's the
introduced.
thermogenic.
that's a thermogenic,
Yeah, sure.
flushed into the water column, eventually making their way into the atmosphere.
Hi,
Here to
Lily.
talk about biogenic, just like what we see in on the tundra. The microbes working on the vegetative matter. You know, as the permafrost thaws, the microbes work on that and release methane. So we're seeing a similar production or similar mechanism in the oceans. But because ocean's a lot more ocean than there is land, it's a greater source. It's a greater
Wow.
potential source of methane.
Wow.
So
Wow.
what their findings found was that uh, it changes how scientists understand methane production in the ocean. So it's not so rare and unusual as previously thought.
Right.
Methane production in oxygen rich environments may be widespread
Damn.
if phosphate is limited.
Damn. Oh, I have to clip
So
this
they,
for Jennifer.
I mean, it's crazy. It's like,
Oh.
oh, not enough phosphate will change our biochemistry, and then we release methane. Whereas if they had enough phosphate, then they release oxygen as a byproduct. That's really really quite astounding.
Woo. I'd say. Yeah. I would say. All right.
So, according to the teens model, less vertical mixing, surface waters could become increasingly nutrient starved. Now, how long have you heard me talk about stratification and
Absolutely. Forever.
shutting off the nutrients and shutting down or decreasing net primary productivity?
I
Well,
know.
it applies here as well, and this creates ideal conditions for methane producing microbes to do quite well. So the result is you get more methane released from the ocean to the atmosphere.
Not a good thing.
So this is alarming to say the least.
Yeah, this is, I mean, this is, when is this
And
from? April? Wow.
when you look at the work of Natalia and Igor,
Yes.
their concern was how much methane they were looking at the terrestrial end of it.
Hmm.
Igor started looking at methane in the on the Eurasian side in the Arctic Ocean, but their concern was how much is there and what's the rate of release. Was it going to be a gradual release, or was it going to be a big old fart, you
Hmm.
know a lot at once? That's something that the scientists who study this, that keeps them up at night, in all
Sure.
seriousness.
Sure it does. I think a lot of these things keep scientists up at night. Yeah.
Yeah, it's absolutely alarming.
I think we need a lot more
So,
research on this.
oh yeah,
Absolutely.
we do.
Hmm.
So the next one, another methane related topic.
The next
uh,
article, we ready?
yeah, yep. Meltwater flushed methane from Greenland seabed during ice sheet retreat.
Oh,
This one,
yeah.
that's why I wanted to talk about it. This one surprised the hell out of me. But when you look at their explanation, it makes a lot of sense. And so this is the Ilul- Ilulissat ice fjord.
Yes. Illutisat
Of course,
Iceford.
yeah,
Mm-hmm.
say that fast 10 times. Anyway, so
Illutisat Iceford.
what
Isfjord.
happened was scientists discovered there's methane hydrates beneath the northwest Greenland continental shelf. It gets destabilized by meltwater and it gets released. That's what they found.
But we didn't know this before.
Apparently not.
This particular. Where's the link to the research? We didn't. That's. It was in
Nature,
Nature Geoscience. Let's see the
nature
research.
geoscience.
Yeah, let me reject the cookies. All right, let's see. Gas hydrate dissolution triggered by subglacial groundwater flushing during deglaciation. So, I mean, obviously there had to be uh, a lot of references before this, but this is pretty wild. Let me see the references. So they pulled it all from a lot of studies, but here we are. Wow. Wow. Wowie wow. Yeah, this is pretty hairy. Mm.
It's absolutely insane,
Mm-hmm.
and apparently it's a fast-acting mechanism, and this may have contributed to past climate events, and could well contribute to future climate change as we lose the ice. Right?
See this graphic. So there's the sediment, gas hydrate dissolution triggered by subglacial groundwater flushing during deglaciation. There's the meltwater, the hydrate dissolution, the hydrate itself, the sediment grain, and then this is oh, see? It shows you right here the discharge and the groundwater. Let me see what does it say. Insert shows the dissolution of gas hydrate freshened by water flow beneath the ice sheet and in front of it to the left. So immediately here, I've got to shut this off for a minute. Immediately beneath the ice sheet, meltwater infiltrated into the subglacial sediment and migrated downwards to a hydraulic gradient loaded by the element potentiometric surface of the water within the ice sheet, which is the dashed black line. So under the GZW, the water flow may have been largely horizontal, whereas in front of the ice sheet, fresh methane bearing groundwater discharged upward into the ocean. Holy shit. This is big. It is.
It
Wow.
is.
I mean, we've been
What I'm
studying this for so long. That's why wow.
what I'm looking for is uh,
Wow.
if they give an estimate as to how many grams they think this will release.
On the
That's
research here, let me see if I can get back to the
okay. So I got
smaller.
the methods there. So okay. So I'm just looking. It might be more of a descriptive uh, thing here. Oh, okay.
Where is it?
83. No, that's let's see something. What did I just see that?
Seafloor depressions? I mean,
MBSF.
this yeah,
What's that unit?
I did not read this article all the way. I have not gone through this. I mean, half the time I don't understand all of the obviously all of the data, but I understand enough to understand what's happening here. Wow.
Okay, here we go.
Where is it in the article or the research?
It's in the article.
The article.
It's oh, if you let's see what figure is that. If you look at figure 3B and then go down to like the second
Oh wait,
paragraph below that figure.
the research in the research itself, right? Are we going down for the re to
It says the paragraph that starts off with uh, headspace, what have you.
all right. I
It
have to
says
just go down
he-
headspace.
head headspace gas measurements.
In the article or the research? Figures. Here we
Uh,
go. The figures. There's different
the Nature
yeah.
Geoscience article.
Oh, okay. I've got to go backwards then. I'm in the oh, that's
It says he-
phys.org.
head.
Major.
It says heads. Hang on. Headspace gas measurements show methane concentrations generally exceeding 10,000 parts per million by volume.
All right, I can't find
That
it.
is well. Let me read the data then.
Yeah, read the
Okay.
data. Read the data
Okay.
because I'm not finding it.
Where concentrations range from 2.3 to 5,281.54 parts per million by volume. 3 low methane samples were recorded at 15.96 ppmvs,
Mm-hmm.
2.3 ppmvs, and 5,281.54 ppmvs.
All right.
We see they report an upper interval with extremely low methane concentration of 2.63 to 23.15 ppmvs, a middle interval of 62.81 to
That's
15,216.78 ppmvs, and a bottom interval beneath 117 values of 8,656.62 to 87,408.41 ppmvs.
all
So
right.
in other
So
words,
yeah, let's go
it's
to the in
there's
other
a
words.
basically the potential is there is a lot of methane there that could be released.
Wow.
That's what they're getting at,
Yeah.
because that's what they're
There's
reporting.
the
And then
article.
you got to
There's
take into account how much area, how much volume is there.
yep. Wow. 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 This is pretty cool. I don't know if anybody. I'll put the links into the article if you're interested. But I mean to the research article. But this is the article that we're going from the meltwater flush methane from Greenland seabed during ice sheet retreat. Yeah, this is pretty heavy. All right. And the seafloor.
So
Oh, listen, let me say something about this. Seafloor includes high resolution 3D seismic imaging from not the United States anymore, right? we're
not
gonna,
not not what's
oh yeah,
not what's coming down the pipe.
yeah,
Nope,
we're gonna do our intermission video soon. Okay, let's
nope.
let's step it up. Okay,
You know, as you and Jennifer have discussed in the past, you know,
for
the
years.
concern is a rapid methane release from the hydrates as they destabilize, and that's going to play a critical role in the climate. Uh, and for those who you have methane hydrates, which are ice-like solids, basically
Mm-hmm.
frozen water with methane trapped inside of it,
Mm-hmm.
and they form under low temperature but high pressure, and they typically found beneath permafrost and deep sea sediments. Approximately 1,800 gigatons of methane is stored in gas hydrates beneath continental margins and permafrost. So it's a big potential. Now, contrast that with methane clathrates, which is basically methane trapped in frozen soil, frozen ground.
Yeah, yeah.
So this is a mechanism that could release potentially, a lot of methane. And what the new findings from this research reveal that meltwater driven dissolution can rapidly destabilize hydrates, even if they appear to be in a stability zone,
Remember, this was
in a
from
stable zone.
23 when they started talking about. I remember that article.
Yeah.
See, from 23. I remember this. Wow. Okay.
So the oceans are starting to release methane. Oh joy.
Oh joy. Oh joy. Well, now that we know that, let's go on to sea level rise. Oh boy.
And here's another interesting thing. If I think there was an interesting graphic in this. Yeah. Let's go down to that graphic that shows the sea level rise, with better observations and clearer
There we
causes.
are. Yep.
That's
Oh, I
really
can't make it
interesting
bigger.
because
It doesn't go
because
bigger.
it
Shoot. Doesn't go
what?
bigger. It doesn't go bigger to the full
Oh,
screen for everybody. Sorry. You'll have to look at the article. Okay.
so what's interesting is if you look at that, 43% of global sea level rise can be attributed to thermal expansion of water, right?
Yeah.
You heat up water, it thermally expands. 43%. Just 3% to reduction in land water storage.
Mm.
So that's what we're up to 46%. The remainder, 54%, i.e., a majority, is the result of melting ice sheets, melting alpine glaciers.
Oh, yeah.
So most Over 50% of the sea level rise is due to melting of ice sheets and alpine glaciers, which is the result of humans introducing shitloads of heat
Yeah.
energy into the system.
Well, sure. And I didn't have anything pulled up to show the differences in the glacier pictures from, you know, 50, 60, 80 years ago, even 100 years ago. And now it's disturbing, it's upsetting, but they'll say it's the greening. It's good for good for the world, the greening. Yeah, okay.
Yeah, and studies have shown that if it gets too warm, plants switch from photosynthesizing to
Right.
respiration,
Exactly. They're not going to do so well.
which means they release more CO2.
Yep. There you go.
So, so that's really the critical thing. But here's another thing. Okay, we talked about earlier with the AMOC slowing. Okay,
Yeah.
so if AMOC is slowing, that means the branch off the Gulf Stream, the North Atlantic drift that
Yeah.
goes towards the North Atlantic,
Uh-huh.
that slows down. So that means what? That means that water doesn't pinch off. So you're going to get a backlog of water.
Oh.
Couple that with the fact that the Earth is rotating and you have westward intensification, you're going to get drastic sea level rise off the East Coast. And some speculations are up to 1 to 3 meters. So
The
you
east
could so
coast of the
Miami
United States.
in the east coast of the United
Yeah.
States because
Which,
the
yeah.
Gulf Stream is not pushing as much volume
Right.
northward. It's remember the Gulf Stream ain't going to stop, but it could
Right.
slow down. It
Right.
the teardrops, the amount of volume that it pushes,
Mm-hmm.
could change, and so
Mm-hmm.
then it kind of wallows behind
Yeah.
because the conveyor belt as it sinks, it pulls that water with it. Well, it's not going to pull that water, so so it kind of back flushes, and then you get the western intensification,
I
so
was
you get the
thinking the
water
same
piling
thing.
up on the western seaboard, the western part of the ocean off the eastern seaboard, and you're
Yeah.
going to see a dramatic rise in sea level off the eastern seaboard of the U.S.
Mm.
Sea
Okay.
level rise is not going to be uniform
No.
across the oceans. It's not.
Remember when Tony used to do his show? See, on he was specifically doing sea level rise at that time, and I remember him talking about similar things that are just now really coming to more fruition that are clearer. Yeah. Wow.
So we're seeing, and of course, as you start melting Antarctica and Greenland and so on and so forth, you're going to see major sea level rises.
Mm.
We have the Thwaites glacier, and
Yep.
is in jeopardy. A lot of the ice sheets down there in jeopardy. If they were to melt, you could see sea level rise about 10 meters or so. If
Yeah.
all of Antarctica melted, you have a sea level rise like 57 meters. But now, that will take a few millennia to do that. But still, you're going to see, significant sea level rises that will inundate all the continents.
I
You know,
wish.
island nations like the Maldives, bye bye.
Yeah. Oh my gosh. I wish I could make this one bigger because it's pretty good graph. In the past, the glacial melt was the largest contributor to sea level rise before it was overtaken by thermospheric ocean expansion overtook at the left. The rate of the sea level rise has been speeding up since 1980, also driven by thermospheric ocean expansion. But you see it here. You see on the graph the years and the land water storage, glaciers, Greenland ice sheet, Antarctic ice sheet, thermospheric sea level, and observed GMSI. So it's an interesting graph if you guys want to go back and look at it, if you're as nerdy as we are, to
Basically, what you can do is you can break it down and by each of the categories and how much they contribute.
yeah,
Uh,
right here,
and
21%
yeah,
goes up. And it changes. This is the global mean sea level acceleration budget, and the left is the global mean sea level budget. But it's sea level in what is it, millimeters, and then the other one is timing. So it's an interesting graph. All right, now that we know we're going to drown, let's go. Let's move on to our last discussion on the eddies, which I learned about from you all about the eddies.
I chose this one because you've been hearing me say for some time that eddies are what really is the connector between oceans and atmosphere, and
Mm-hmm.
that eddies help,
Mm-hmm.
uh, you know, help facilitate what takes place. So, for example, an eddy can either bring materials in from the atmosphere into the ocean, and train the heat and train the CO2, gas, and so on, or it could be a source of moving materials from the ocean to the atmosphere, depending on which way the thing is rotating. Is there a downwelling in the middle? Well, then it will pull stuff from the atmosphere into the ocean. There's an upwelling, it will push stuff from the ocean to the atmosphere. And then you do all the calculations all over the place and you find out what the net is. Well, look at the opening sentence here. New research reveals a powerful yet overlooked driver of climate change, intensifying ocean eddies.
Ocean eddies. Mm.
Again, you've heard me talk about this ad nauseum. And it is these eddies. They break off from the major, right? We talked about how the ocean, how the Gulf Stream, there's a bunch of all these little eddies that pinch off.
Yep.
They redistribute heat and nutrients and amplify climate extremes in key coastal ecosystems.
Well, at least it's being studied here still, University of Miami.
Yeah,
And
the Rosenstiel School
mm-hmm.
of, you know, it's a major a research institute.
It
Pretty,
is.
it's a good research institute. So they looked at the Gullis the current, which is off of southeast coast of Africa,
Mm-hmm.
and they looked at the fast and narrow western boundary current because of the rotation and Coriolis and so on. Western boundary currents tend to be fast, they tend to be narrow, and uh, and they tend to be deeper. Whereas on the eastern side, they're slower, they're wider,
Right.
shallower, and so forth. And what they found was that eddy activity is reshaping the Agulhas current, intensifying adjacent coastal temperature extremes. Um, I still have to
Little
edit it, but
eddies.
I did a long deep dive video
Oh,
about
okay.
the role of eddies in the Indian Ocean
Oh,
and how
okay.
they
That'll be cool.
it, that's like an hour long video. I just got to get my
Okay.
ass in gear and edit the damn thing. But
Okay.
yeah, but it's the same thing. Eddies are what help facilitate movement between the atmosphere and the ocean,
Yep.
and it
These are the
mixes and so
eddies.
on and so forth.
Mm-hmm.
So they published in Nature Climate Change. They identified
Right.
small frontal instabilities about 10 kilometers across with meanders of the current that transfer heat, salt, nutrients between open ocean and coastal environment. More eddy activity is accelerating surface warming in the Agulhas while simultaneously enhancing hidden upwelling that
Oh.
cools deeper waters.
Oh
So
boy.
basically, you're moving the heat about.
Yeah, our poor oceans. And
You know, if you're
everything that
moving,
lives in them.
yeah. So if you're moving the warmer water from the deeper layers up to the surface layer, that could flux the atmosphere and contribute to atmospheric warming.
All right.
This combination, along with the onshore encroachment, also driven by eddies, will create more extreme conditions in shelf areas. Now, this is important. Both frontal eddies and meanders pump deep, cold, nutrient rich water up onto the shelf. Sometimes it's called Ekman pumping, Ekman
Yeah, we've
transport.
talked about that.
We talked about
Mm-hmm.
that.
Mm-hmm.
Potentially enhancing productivity while farther offshore meanders trap heat and salt closer to the surface. The result is rapidly warming surface waters above cooler waters at depth. So that means you stratify the ocean column. You have warm water on top, cold water below. And then maybe in the open pelagic zone, you're not going to get nutrients into the photic zone for productivity.
The
You may
photic
inject
zone.
you may inject nutrients onto the shelf to have productivity, but not further off.
Okay.
So the point is that don't overlook eddies. They're a very important mechanism.
And this
And you've
goes
heard me
back
talk
to
about
the.
them.
Mm-hmm.
You've heard me
Wow.
talk about them time and time again.
Yeah. All right. Okay. Now, everyone, we are taking an intermission to then move on to the actual pièce de resistance of the rest of the show. It's a long one tonight. Yes, it is a long show, and I need to set up that video. So hang on. We have a good one, and enjoy it, and we will be back.
Scientists across the country are expressing alarm as the Trump administration dismantles another tool for understanding how the planet is changing. Starting this month, more than 900 deep-sea ocean sensors will be pulled out of the Pacific and Atlantic Oceans off the coasts of Washington, Oregon, Alaska, North Carolina, and Greenland. Researchers say these are some of the most critical ocean observation tools we have.
What is an ocean observatory? An ocean observatory is a suite of ocean-going instruments and sensors. They are deployed on long-term oceanographic missions to collect data about our oceans. They have a long-term power supply and permanent communication links that feed data directly to scientific laboratories. Collecting data on things like currents, hydrothermal vents, and species that inhabit the seafloor. Scientists at 3 oceanographic research institutions have observed ocean data for the last 7 years, and will continue to do so for the next 23 years.
This was a decades-long, about $380 million research project. Hundreds of sensors you described. Some of them set on the surface of the ocean, some of them went down hundreds of feet. The way to think about this is like an ongoing medical checkup on the health of the oceans. How salty is it? How warm is it? How do the currents move in the ocean? Where are they moving? How are the fish doing down there? How is the ocean responding to climate change? I think it's hard to overstate just how critical oceans are to life on Earth. They regulate our weather, they provide food for millions of people all over the world. Over the last few decades, they have absorbed an enormous amount of the carbon pollution that we put up in the atmosphere has been taken up by the oceans, thus delaying some of the more negative consequences of climate change against us. These sensors were looking at all of those things, and now we are, in essence, stopping that research project totally.
The National Science Foundation's Ocean Observatories Initiative is a cutting-edge approach to access. Where we were once limited by the constraints of data collection at sea, we now have an ocean of constant data streams. Each array is equipped to tackle science themes crucial to the advancement of oceanography, from climate and the global carbon cycle to coastal dynamics and plate tectonics, from ecosystem health and transport processes to submarine volcanoes and the deep biosphere. From our underwater observatories in the coastal and open ocean, we bring the ocean to you.
So if this is such an important project, what exactly is the Trump administration's rationale for dismantling it?
I wish I could give you a clear answer on this. The National Science Foundation, which runs this, put out a statement justifying this that is incredibly hard to parse. Let me just read this statement. Here's what they said, quote, "The decision to de-scope aligns with NSF's wider strategy of a nimbler approach to prioritize support for evolving scientific priorities and emerging technologies, as well as smart life cycle management within its research infrastructure portfolio."
When a problem is approached in a new way, Complexities vast as the ocean become simple solutions. Introducing the Sea-Track SP48, your reliable, cost-effective, simple USV solution.
Climate change. One researcher I was in touch with today described this as an intentional choice to embrace ignorance.
The ocean is basically the life support system for the entire planet. No ocean, no life.
The oceans are changing in not very predictable ways. There's so many things we just don't know.
The oceans are tremendously important over a wide range of societal issues: energy development, food security, natural resources.
In order to be able to forecast our weather or understand how our climate is changing, we need to understand the role that the ocean plays in that. And the better we can understand how these processes work, the better prepared we'll be to understand how and why our weather and climate are changing.
The oceans are vital to the future of humanity.
We're living in the Anthropocene. According to some researchers, that started in about 1950. The most important aspects that are changing our entire Earth right now are created by humans. So we owe ourselves the understanding of what it is we're doing to the planet.
And the ocean has been protecting us from a lot of this for decades, but it can't do it forever.
The ocean is not like a laboratory. We have like this black box and you can kind of control everything that goes in and out of it. You have to put your data in context to make sense of it. And that's why you need an observatory.
So OOI is a research observatory funded by the National Science Foundation, and our mission is to make sophisticated measurements in difficult locations for a very long period of time.
Our role is a facility. We take the data and we make it available to anybody that wants to use it.
It allows us not only to look at things like process studies, but also studies related to climate, which require at least 20 years, and we are hoping to run the observatory for 30 years.
We need to find early and mid-career people who don't know what they can't do, so they're willing to try things.
And I think as we move forward, I think what will be increasingly good is as we plan enhancements of the OI or other experiments, that we can actually involve young scientists in that planning, and that's already happening.
From a personal standpoint, it's just kind of been a lifelong dream of mine to study the deep sea. I really live and breathe science, and so any opportunity that I have to get out and participate in acquiring data or deploying instrumentation that's going to acquire data is just really exciting and satisfying.
Enormously important phenomenon happening in the oceans right now. The first one is in the Pacific Ocean. This is what is being called a super El Nino. This is characterized by incredibly warm ocean waters in the Pacific, which we are seeing right now. A strong El Nino can affect weather patterns all over the world, and this is now gearing up to be a potentially record-breaking El Nino. That's one event in the Pacific. Switching across to the Atlantic is a second system that goes by the acronym known as AMOC. AMOC is this colossal conveyor belt that moves ocean currents all over the globe, particularly in the North Atlantic. Some researchers have been detecting a signal that warming, particularly warming in the Arctic, could be disrupting AMOC and even overturning it. And if that were to actually happen, this would be considered one of the most grave tipping points that scientists fear could happen with regards to climate change. If that were to happen, this would cast incredibly harsh winters over Europe. It could send much more fierce hurricanes to the east coast of the United States. Most problematically, it could seriously distort the rain that feeds millions of people in Africa, in Asia, in South America. And so the researchers that I have been in touch with are arguing this is exactly the time that you do not want to be, quite literally, taking your eyes off the ocean.
Seas are rising, the ocean is warming to record highs. So what is the Trump administration doing? Tearing out one of the systems we use to watch the ocean change. Right now, the National Science Foundation is dismantling the Ocean Observatories initiative, about 900 ocean instruments that cost roughly $370 million to build. Crews have already started pulling the first array out of the Pacific. For a decade, this network has tracked marine heat waves, ocean currents, and coastal flooding risk. It's run out of Woods Hole, Massachusetts, and one of the arrays once sat just offshore Martha's Vineyard. Why? It lines up with Project 2025, which called NOAA's research office the source of much of NOAA's climate alarmism, and said most of its climate research should be disbanded. Congress restored the funding twice. They're tearing it down anyway. This is the real danger of the anti-science MAGA movement. It doesn't stop the threat, it tears down the tools that warn us. NOAA gutted, the National Climate Report killed, climate.gov gone, now the ocean sensors. We're flying blind on purpose, and that's how people get hurt. I'm meteorologist Chris Gloninger. Follow me for more on weather and climate.
Okay, so this is the pièce de résistance of upset, and it is short-sighted, and it is dangerous. And, you know, there was a person that I had a little back and forth with about how, oh, the reason why they're cutting all this out is because they're upgrading and it's going to be just all drones. And that was ridiculous because it's a multi-pronged, that's just one piece. That's why I put that in the video to show you. The drone is just one piece. So, Jim, let's hear your take on all this.
That statement that the reporter said about the, NSF saying it's going to be nimbler. What the hell does that mean?
That's what he was saying on PBS. He goes, what does it mean? You know, the NSF saying all this.
That just sounds, well, I'm not, that sound like that. It is just complete bullshit.
Yeah.
I mean, the oceans are a big place. And if you really want to understand what's going on in the ocean, what the processes are, what the, the vertical, horizontal profiles of, you name it, you need to have a lot of stations all over the place.
Yes, absolutely. And
you need to have moors at the surface at 100 meters, 200 meters, what have you. You need to have them all over the place. Because otherwise, we're going to do what? I mean, we're losing the satellites. Now we're going to lose the mooring. We're going to go back to oceanography, how it was done in the 1940s. You hop on a vessel and you take points in time measurements. That's not going to tell you diddly squat.
No.
I mean, and that's assuming that you can even get the funding to get a research vessel. This is disgusting. This is infuriating.
I know.
And it's just all because you have climate deniers and you have that idiot, that orange idiot who doesn't give a rat's ass about anything except money for himself. And
I'm going to show you.
We're going to now have to rely on Copernicus, the European space agencies. We're going to have to, and the Chinese. The Chinese, by the way, if you look at a lot of the papers that show up in AGU and JGR and all that kind of stuff there, a good, well over 70% are Chinese authors, Chinese scientists.
Oh, they're going to head everything. And they're brilliant people. I wanted to show, this was the IOOS, and this is their newsletter, and this was the organization with, the 4 different organizations coming together to run all this research. And there was some clips, but I don't think they have the update on how awful it was. And by the way, yesterday was Ocean Awareness Day or National Ocean Day or whatever it was. It was yesterday. So, I mean, celebrating the oceans, and that wasn't lost on me, considering we were going to do this show.
In light of this, that to me this comes across as a sick joke.
Yeah, exactly. But they have history. I'll have these in the show notes. But it's a very interesting the way they put it together. Let me see, meet it. Where is it? Communications data. They have all the data. Oh, listen, they have the radar, the marine life, the ocean enterprise, the ocean technology. I mean, there's so much here, and the regions. I mean, it's all, so much of it's going by. Not all of it, not all of it is going away, not every single thing, but most of the things that really make it work. Look at forecasting hazards. That's a big thing in now. And integrated ocean data are enhancing scientific ability to forecast environmental changes and dangerous events. But no more, not in the United States. So we're going to have to rely on, like you said, China. We have to rely on other countries. We have to rely on, because of the anti-science, clueless moron United States. And I'm sorry, but it's just, and the deniers and the people that follow the Heartland Institute, the people that worship Project 2025, and the people that really, really are anti-science baboons. And that's nice.
This is going to create major deficits in our data, which will greatly negatively, adversely impact our analyses as to what is actually happening. This is disastrous. It just is. You lost the satellite, but it's similar to like what they did with the National Weather Service. They cut the funding for the National Weather Service, and now tornado coming. Well, you find out about it as the funnel is rumbling down your street. You're not going to get the tornado warnings now.
United States got lucky last year.
Now we're not going to get the notices about how severe El Nino is going to be. We're not going to get
well, we will, but we're not going to get it from this. I mean, I think what's going to happen. Well, listen, we're going to lose the ability to have years of data. I mean, this was supposed to go on for another 20 years, another 20 years with all those bright young researchers. But this was the article you sent me from Anchorage Daily News. And so it's a portion, it's not the whole thing, but the most ambitious ocean monitoring networks ever built will go dark. When scientists board a research vessel and motor off the Oregon coast to pull a research buoy from deep out of the Pacific. Why? And some people are saying so that the people won't know when they destroy the ocean, how they're destroying it from mining it. The buoy was 260 feet below the water surface, will be removed June 16th. That's coming right up from the Ocean Observatories Initiative, a network of more than 900 sensors, 386, we heard that, but it's from the NSF, who is now compromised. The NSF is compromised. I don't even know who runs it, some Trump lackey. Funded by the foundation, the observatories have tracked everything from ocean circulation and marine ecosystems to climate change and extreme weather. Its data has been freely available and has informed more than 500 scientific publications. 15 to 20 years, another one. I mean, and so many people say, oh, it's just a gravy train. Oh, it's just bullshit. Oh, what did they get out of it? And I can't stand these people that are so ignorant. So they said it's not a cancellation, but a de-scoping aligned with a wider strategy of a nimbler approach to prioritize, and this is what he read in the video, prioritize support for evolving scientific priorities and emerging technologies. And that's why I showed the drone. But are the emerging technologies, who's going to make them? Are these technologies, are they, other like oligarchs? I mean, the company that made that particular drone, these two people were oceanographers. These people were from Woods Hole originally and all that. But you don't know what this means, this emerging technologies. Look at what we're seeing with data centers. Look at what we're seeing, who's going to be running the show with these emerging technologies, at least until the NSF is not corrupt, which I'm sorry.
And emerging technologies, are they even going to be funded?
Yeah, we don't know. No, they'll be privatized. Everything's going to be privatized. And then they can play with the data. And again, I think it was Dan that said it. Let me see if I can find his comment. Dan said they don't want you to know how much they are screwing up the oceans when they start mining them. And I mean, it sounds plausible because we're supposed to, we want all those minerals. So an El Nino event. Oh wait, but for the scientists who built and operated the system and the researchers, educators, and students who rely on its data, the timing feels particularly punishing. And in the El Nino event, which disrupts the weather patterns, which we've talked about tonight, and supercharges marine heat waves, is predicted to arrive along the Pacific coast this summer. So before 2027 even. One marine heat wave is already pushing unusually warm water off California. Without the Oregon and Washington moorings and the network of underwater gliders, the Ocean Observatories initiative operated in the region, researchers say they'll lose much of their ability to measure what's happening below the surface, which is precisely where the most significant oceanographic signals are. Crippling loss of information. Crippling loss. So we're fucked in the oceans. And I don't care what anybody said. This is a crippling loss.
It is.
Yeah.
It's disgusting.
And what's 48 million a year for all of that data compared to what are we spending? 48 million a day fighting Iraq for nothing?
A billion.
Yeah, disgusting. But science takes a back seat to everything. Science takes a back seat to corruption and the orange grifter. Sorry, we're angry about this. I knew I would get mad. And the of course always the Guardian always has good stuff. And some of my writing, I was looking and using some of the Guardian stuff, pilfering from the Guardian, but it is just awful. It is.
It's it's going to leave the U.S. back in the Stone Age as the rest of the world makes advances in the science. Well, for example, now electric vehicles. We're seeing, for obvious reasons, we're seeing a surge in electric vehicle. Do we have electric battery research for electric vehicles going on in the U.S.? No, that's been cut. The infrastructure bill that Biden passed, that's been cut. So here in town at a Fred Meyer, they built a little charging station, something like about 8 or 10 ports, where if you have an electric vehicle, you can charge it. Well, all that infrastructure stuff has been gutted.
Right.
We got to drill. Well,
even the Coast Guard are getting screwed. There's a whole presentation here. Even the Coast Guard. I mean, this is like disgusting. In the document, there's partnerships. Even Shell Oil. Ugh, as disgusting as that is. But they needed to. They were working with them, and it's just overwhelming. They made a plan in 2015 to meet the nation's requirements and all the stuff. There's just so much. It's so much. I tell you should go to this website just to see. And then the data and regional data port. To say there's going to still be data available from what was there, what they did. That's not totally where people are going to get laid off. That's what I was reading. But interagency partnerships, they had summits, they had all kinds of stuff, and that's the one that's going away. So I suggest you read the Guardian article because it was a good article. And what else, Jim? I mean, I know that was the pièce de résistance. I know that we really are upset over this, and it's tragic because, like I said, even the military, how can we, this is the data was available to all worldwide and the military. That's probably another thing that these fascists in charge don't like. Oh, we're going to provide data to other countries, in this age we live in, the Moronocene.
it's depressing. It pisses me off.
Yep.
It just, I'm just glad I'm not a young person just getting out of grad school trying to embark on a career in oceanography.
Let me see what Brett says. Yep. The harsh truth most of you are unable to accept is they will poison every plant. No, we're accepting it. I'm already collapse accepted. I know they're going to do this. They'll consume every tree. They'll traffic every child. They will foreclose every property. That's what we're seeing as this goes on. I'm with you. I see it. I've accepted that these horrible things are going to happen, but it doesn't mean you can't get angry. Because what would we be if we weren't angry, And anger brings local activism anyway. What did you say, Foggy? Wait, she's got one here. They want to give us a good send-off party. Cheers. Yeah. Yep. I mean, I didn't want to end the show angry and upset, but it's just fucked up. This is happening. It just is.
I'd like to give the oligarchs a send-off party to the Oort cloud.
Nadia, the distributive effect is the point. Military adventures socialize the costs, and the profits are always privatized. Of course. So we'll see what happens in the future, with any of this. I mean, they're going to have to. This government is going to have some way, and yes, I can see more of it privatized. But this organization was not. It was working with private. It was partnering with all kinds of organizations. Oh God. Oh, I don't want to hear this, Nadia. Flush the elite. All right, we're going to have to do a flush. Are we ready to do a flush? Are we ready to flush a bunch of things?
Yes, we're ready to do
All
a
right,
flush.
we're going to flush. We'll flush the elite, not the climate elite. All right, let me set it up, and all right, we'll do a flush. Okay, that's one flush. And let's see, flash flood. What do you want? That's Catastrophuck's best album, Oligarchs to the Oort Cloud. That was good. Oligarchs to the Oort Cloud. Oh my God. Listen, we covered a lot tonight, and it was a lot of maybe over some of our heads, or a lot of science and all that. But thank you everyone for being here. Oh wait, what do we want? Oh yeah, it was radioactive green flush. Yeah, radioactive. We do that. For those of you that aren't here, we have a flush of the day, and we flush that. Anything you want to flush, Jim? We'll do one more flush. I already know who you want to flush.
Yeah, the orange turd.
All right, we'll flush the orange. We'll flush.
And his whole regime.
All right, we did our flushes. We have had a 2-hour show, but usually when Jim's with me, our shows are quite long, and that's why I'd like to do the intermission video. I thought, I really wanted to put something together that I thought would be helpful for everybody to learn from, so I did clip this together. If you want to go back, maybe I'll make it available, outside, and just clip it, for a short. So Jim, why don't you close up, and I'm going to thank everybody for coming. And oh wait, real quick, I have an announcement. Friday night, Scott, the End of the World Party, will be with me Friday night, 9 p.m. Eastern. We are going to talk about AI, and Scott has his amazing takes as usual. He's been the guest before, so look forward to the End of the World Party. Okay, Jim.
Well, first of all, thank you to everyone for joining us. We covered a lot today. I haven't been on in a while due to some personal stuff, but
Both of us.
This is we wanted to touch upon what the state of the oceans currently is at. Looking at AMOC, El Nino, sea ice, sea level rise, all that kind of thing, all going to impact us because oceans drive the climate, but in addition, as I've just said many, many times, phytoplankton provide 55 to 80% of atmospheric oxygen. If the phytoplankton numbers drop, if their productivity drops, the amount of oxygen they release to the atmosphere decreases, which impacts us adversely. And the oceans are dying. And now we're not going to even be able to get the data to understand exactly how bad the situation is and what the trends are. And let's be blunt, the oceans die, so do we. And that's just how it is. So it's very sobering, but
add that to the bees. Everybody plant flowers and plant your victory gardens, and let's get the pollinators out there.
But we do need to, as disturbing as the information is, we can't stick our heads in the sand either.
And we don't on this channel.
Because it's sticking our heads in the sand ain't gonna make the problem go away. It's just like when the orange herd said, well, if we don't record all the COVID cases, then COVID didn't happen. That's not how it works. So if we don't record what's happening in the ocean, the oceans aren't in bad shape. No, it's not how it works there, Donnie boy.
Yeah.
So
exactly.
We are in this century is going to be one of major transition for the planet, for humans, for species. Humans will probably have their numbers greatly reduced, and
eventually.
My worries are that the number of species we take with us, as we ourselves are basically laying the seeds for our own extinction.
Yeah,
and
that's
and planet Earth, after humans are extinct, planet Earth will continue on, will recover, evolution will proceed, new species will fill the available niches, just humans won't be around. And maybe that might be a good thing for the 4.5 billion years of life that planet Earth has left.
Of course, we never ever prognosticate, or we don't tell a time. I don't have the magic fish or a crystal ball, because we don't, and we don't know. But we're headed in a direction of yuck. But as I always say, local activism, and that's what I'm involved in right now. Right now, I am doing things here, and I always do. All right, guys. Peace and love, and we love you and all that good stuff. Thank you for being with us. We just absolutely love you, and that's why I'm here. And no, I'm not doing Thursdays for a while. I can't do the afternoon. I am so flat out. I'm helping my homeless friend and all the things that I'm doing, which you know about because I make shorts and I do all that stuff. And Channel Warhorse, we love you. And Flash Flood Area, Groove Drain, everybody, Poppy, everybody, thank you. Good night. Good night. Good night.
Good night, everyone. And remember, make time for yourself. Listen to some good music.
Yeah, man.
Good night, everyone.